Before we jump into different consensus mechanism, let us look at how the consensus mechanism works. Basic parameters that define a consensus mechanism are decentralized governance. A single central authority cannot provide transaction finality. It has to be the group of users or stakeholders on the network providing the finality to a transaction before it becomes part of the blockchain. A quorum structure. Nodes exchange messages in predefined ways, which may include stages or tiers. Authentication. The process provides means to verify the participant's identity. Integrity. It enforces the validation of the transaction integrity, for example, of which could be mathematically using cryptography. Non-repudiation. This provides means to verify that the supposed sender indeed sent the message. Privacy. It helps ensure that only the intended recipient can read the message. Fault tolerance. The network operates efficiently and quickly even if some of the nodes are down or slow. Performance. It considers scalability, throughput, latency, and liveness. Between different consensus mechanisms, there are significant differences in how they use these parameters. These parameters are implemented through 4 main techniques within cryptography that use mathematical formulas to try to ensure security and privacy. These techniques include private keys, hashing functions, and hierarchical deterministic keys. Now that we have covered the working of and the parameters that define consensus mechanism, time to look at some specific consensus mechanisms. We will start with proof of work, also abbreviated as POW. Let us consider number combination locks. Proof of work consensus mechanism works in the same way. If a combination lock is currently logged, then the right combination of numbers is needed to open it. If for any reason the combination is forgotten or lost or not known, then the only option left is to keep on trying different combination until lock unlocks. So getting the combination of the lock is proof of work which anybody can validate very quickly by using the same combination you have discovered to open the lock. The idea for proof of work was first published in 1993 and was later applied by Satoshi Nakamoto in the Bitcoin paper in 2008. Proof of work consensus is the mechanism of choice for the majority of cryptocurrencies currently in circulation. The proof of work consensus algorithm involves solving a computational challenging puzzle in order to create new blocks in the Bitcoin blockchain. This process is known as mining, and the nodes in the network that engage in mining are known as miners. The mathematical puzzle requires a lot of computational power, and thus the node who solves the puzzle as soon as possible gets to mine the next block. The steps involved in the proof of work consensus mechanisms are as follows. New transactions, once created, are broadcast to some of the nodes. The transaction is signed using transaction initiator's private key, which gives the authorization to spend money, and also signed transaction contains all information needed to execute the transaction. Nodes receiving these transactions has predefined criteria to validate such transactions. The invalid transactions are discarded, and valid transactions are propagated to other 3 or 4 connected nodes. This approach ensures that valid transactions reach to all nodes within few seconds. Each node collects these validated transactions into a block. Miner nodes work on finding a difficult proof of work for its block. This concept already been covered in earlier segments, how miner nodes take hash of previous block, transaction data, timestamp, and a random number nonce to compute the hash of current block, which is less than network prescribed difficulty level. When a node finds proof of work, it broadcasts the block to all nodes. Nodes accept the block only if all transactions in it are valid and not already spent. Nodes express their acceptance of the block by working on creating the next block in the chain, using the hash of the current block as the previous hash. Once the block is appended to the blockchain and sufficient subsequent blocks are added, the transaction is confirmed on the public ledger and in principle is accepted by all the nodes. Proof of work as a consensus mechanism is used by following blockchain protocols: Bitcoin, Ethereum 1.0, though Ethereum 2.0 has moved to proof of stake, Directed Acyclic Graphs or DAG, Colored Coins, Factom, Coin Prism. The list is not exhaustive but gives the name of few widely used protocols. In the steps explaining how proof of work works, we came across a phrase "not already spent" or preventing double spend. Now, what is the double spend issue? We will look at it from Bitcoin example. Satoshi's original intention in using a proof of work mechanism is to solve double spend issues and ensure the integrity of global state of Bitcoin blockchain network. Let's say Alice sends 10 Bitcoins to Bob, and at the same time or later on, she pays Catherine the same 10 Bitcoins. We could end up with the following three situations. The first transaction goes through the proof of work and is added to the blockchain when the second transaction is submitted. In this case, the second one will be rejected when miners pull it from transaction pool and validate it against the parent block. Second scenario, both transactions are submitted simultaneously and both go into the unconfirmed pool of transactions. In this case, only the first transaction gets a confirmation and will be added in the next block. Her second transaction will not be confirmed as per validation rules. The third scenario could be both get confirmed and are added into competing blocks. This happens when miners take both transactions from the pool and put them into competing blocks. The competing blocks form a temporary fork on the blockchain. Whichever transaction gets into the longest chain will be considered valid and spent, and the other one within the block on the short chain will be recycled. When it is reprocessed, it will be rejected since it is already spent. In this case, it may take few blocks to get the other one recognized as the double spent one. Let us look at the advantages and disadvantages of proof of work. Energy consumption. Proof of work consensus, which uses a network of powerful computers to secure the network, is extremely expensive and energy intensive. Miners need to use specialized hardware with high computing capacity in order to perform mining and get rewards. A large amount of electricity is required to run these mining nodes continuously. Some people also claim these cryptographic hash calculations are useless as they cannot produce any business value. At the end of 2018, the Bitcoin network across the globe used more power than Denmark. Vulnerability. POW consensus is vulnerable to 51% attack, which means, in theory, dishonest miners could gain a majority of hashing power and manipulate the blockchain to their advantage. Centralization. Winning a mining game requires specified and expensive hardware, typically an ASIC type of machine. Expenses grow unmanageable and mining becomes possible only for a small number of sophisticated miners. The consequence of this is a gradual increase in the centralization of the system as it becomes a game of riches. On the flip side, it requires huge computing power and electricity to take over a proof of work based blockchain. Therefore, proof of work is perceived as an effective way to prevent denial of service or distributed denial of service attacks on the blockchain.